Hi everyone, welcome to Yourpedia. This is Chandrasekhar, Faculty of Electrical and Electronics Engineering at Yourpedia. You all know that BEL announced its exam. The examination is on 31st of March. So we released a module that is to prepare a BEL exam through questions. Almost thousands of questions, like 3,000 to 4,000 questions we are going to provide you for your BEL examination preparation, right? In the form of video, in the form of test series. By all means, we are providing near to approximately 5,000 questions we will be giving in the form of videos and test series in the form of classes and all these things. So I suggest you at this time, in this short span of time, it is always better to solve as many questions as possible. Now in this video I'm going for the network analysis explanation. We started a module of this practice through questions for your BEL examination preparation. You can join this module, it will be really beneficial for you. So in this video I'm going to discuss some 20 questions from network analysis in the direction of BEL examination, right? The very first question is yes. The very first question is yes. Yes, what is saying? In the circuit shown below, Vs is the constant voltage source and IL is a constant current load. The value of IL that maximizes the power absorbed by the constant load is. So this is very simple. Maximum power transfer theorem. Maximum power transfer theorem. So this is a current source, but whether it is current source or voltage source or whatever it is, for maximum power transfer, the load impedance must be equal to source impedance. See, for maximum power transfer theorem, for maximum power transfer, for maximum power transfer, yes. See, imagine load impedance is RL. In place of IL you keep RL. RL must be equal to R. If that is the case, this is the circuit, this is the resultant circuit ma. Yes, this voltage is how much it is? Vs, and this is R, this is also R, and current through this one is IL. Yes, current is same. Now what is IL? IL is equal to Vs by 2R, sorry. IL is equal to what? Vs by 2R. The value of IL that maximizes the power absorbed by the constant current load is. I am assuming this current source as is having a resistance of R. Then only this resistance and this resistance both are equal, then only maximum power is going to transfer according to maximum power transfer theorem, MPT. Right? So load resistance must be equal to source resistance, and the current through this one I am not disturbing, I am making it as IL only. Right? Yeah, IL only. If this current is IL, this current is also IL. IL is equal to voltage divided by total resistance. R plus R is 2R. So option is B. Let's see for the other options also. If IL is equal to V by R, it means to say that this is not having any resistance. If yes, current is infinite. No, it is not possible. Current is not infinite. Vs by 4R is anyhow wrong. Option B is perfectly suitable, right? Next question. See, need not to go for the other options. Okay, Vs by 4R not possible. Why? Because this is R, this is R to R, right? Vs by R, this should be 0, which is not correct. If this is 0 means short circuit, which is not correct. Infinite, yes, infinite power is not possible, right? Next question, please. Any network of linear impedances, okay, the current flowing at any point is equal to the algebraic sum of the currents caused to flow at the point by each of the sources of EMF taken separately with all other EMFs reduced to 0. This statement represents. He just twisted the statement. Okay, this statement is of superposition theorem. Yes, superposition theorem. Yes, superposition theorem. What superposition theorem says? Superposition theorem. What superposition theorem says? The response in any branch, total response in any branch of a linear bilateral network consisting of several sources and impedances is equal to sum of the individual responses When you are finding individual response, remaining all EMFs must be 0, currents must be 0. The same it is. It is superposition theorem. Option is D. D for Delhi. Next question. Find the Thevenin's equivalent circuit parameter for the given network. Okay. So Thevenin's equivalent with respect to terminals A and B. These are the terminals A and B. When you are finding Thevenin's equivalent, as Thevenin's theorem says, you stand at that point. Find the open circuit voltage. Those terminals are already open, and find the equivalent impedance. First, let me find RTH. What is RTH? Thevenin's resistance. We have to find. When you are there here, short circuit the voltage source, open circuit the current source. When you are finding Thevenin's equivalent or Norton's equivalent, short circuit the voltage sources and open circuit the current sources when you are finding impedance, right? If you short it, okay, 50 in parallel with 200, RTH is equal to what? 50, let me write, 50 in parallel with 200, that is equal to 50 into 200 divided by 250. 55s it is gone, 540s it is 40 ohms. RTH is 40 ohms. And sir, what is VOC or VTH? VOC, sorry, it is not VOV, it is VOC. It is equal to V Thevenin is equal to, yes, write it. So this voltage you want, convert this current source in parallel with the resistance as voltage source in series with the resistance. Yes, we can do it very easily. Let me do that. We have a voltage source here, and have a resistance here. Convert that into this way, so this is the voltage. It should be upside minus downside plus, right? Upside minus downside plus, right? Or we can take, or let me take the circuit as it is and do in another way. Why to go for this source transformation? We have 125, 50 to 200. Yes, 125 volts, 50 ohms. Yes, this is yes, and we have a current source here. You may be thinking, sir, first current source, then resistance. Both are parallel, na? Either of the ways is correct. 2 amperes, 200. Yes, this is 2 amperes and this is 200 ohms, right? This terminal is A, this terminal is B. If I convert this current source in parallel with resistance as voltage source in series with resistance, I'm going to get this one. This is 50 ohms, right? And this is 125 volts. Yes, 200 in parallel with 2 will become, yes, that resistance is as it is here, 200 ohms. And what is this voltage? This is minus, this is plus. You are going to get it as 200 into 2, 400 volts. Now these two are both are in addition. How can you say plus is connected to minus, minus is connected to plus? Now let's take the current in this one. As I. I is equal to 400 plus 125. 525 divided by, it is 250. Now this is A, this is B. You want VAB. That current is entering here. So I'll write plus minus VAB. I'm going to write the KVL minus VAB plus 200 into 525 divided by 250 minus 400 is equal to 0. Solve it, you get the VAB. Right? Yes, 0, 0, gone. Okay. 5 5s it is, 5 1s, okay. 5 5s, yes, 5 5s. Again 5s will go, 5 2s, okay, 10 and 5 1s. So 21 into 2, 21 into 20, I think it is 410. 20 times 20 is 400, yes, 20 into 20 plus 1, 420 it is, sorry, 410, 20 minus 400 is equal to 20 volts. How much it is? 20 volts. Observe here, 20 volts and 40 ohms. Option is C. Option is C, right? Let's go to the next question. Next question. A 10 ohm resistor, a 1 ohm, 1 Henry inductor, sorry, not 1 ohm, 1 Henry. A 10 ohm resistance, 1 Henry inductor and 1 microfarad capacitor connected in parallel. The combination is driven by a unit step current. Under a steady state condition, the source current flow through only resistance. Okay, sorry, I mistaken. There is a resistance, there is a capacitance, and there is an inductor. Sorry, previous was wrong. I thought only resistance and capacitance. And this is excited with what source? This is excited with what source? There is an inductor. This is excited with what source? Unit step current, means simply DC. Unit step current, sorry, unit step current. Unit step current means what is the difference between DC and step? If you close at t is equal to 0, a DC source you are connecting at t is equal to 0, that is called a step. If that DC is there since long back, that is DC, right? I is DC. For DC input, capacitor behaves as open circuit, inductor behaves as short circuit. Inductor behaves as short circuit. This is an open circuit. This is an open circuit. No current through this. If it is a short circuit, entire current will follow shortest path. Yes, at steady state for DC, inductor behaves as short circuit, capacitor behaves as open circuit. All three are in parallel. As it is short, total current is going to flow through only through inductor, right? He is asking very clearly under steady state, under the steady state condition, right? Next, the time constants RL and RC circuits are respectively R is equal to 1, L is equal to 1 Henry, C is equal to 1 farad. What is time constant formula? What is time constant formula? Tau is equal to RC for an RC network, for an RC circuit, Tau is equal to L by R for an RL network or RL circuit or network. It may be series RL or parallel RL, whatever it is. So for the first one, what is the answer? You are going to get R into C, 1 seconds. Second one, yes, L by R, that is also 1 by 1, 1 second. Answer is 1 and 1. Option is A. Option is A, right? Next question, please. In the current source shown in figure, the effective resistance faced by the voltage source is, means he is asking V by I. He want V by I. Okay. So this is I. So this is at this node, apply KCL. This is I. This is I by 3. This will be I minus I by 3. I minus I by 3. This is 2I by 3. 2I by 3. I by 3. Let me write it clearly. 2I by 3. This is plus, this is minus. Write the KVL. This is plus, this is minus. By writing KVL, minus V plus 3 into 2I by 3 is equal to 0. So from this one, V is equal to 2I. From this one, V by I is equal to 2 ohms. V by I is equal to what? 2 ohms. Option is B. Right? Next question, please. In the circuit shown in figure, if I is equal to 2 amperes, he is saying that this particular current is 2 amperes. Okay, that particular current is 2 amperes. Then the value of the battery voltage V will be, he is asking about this V, this V. If you see carefully, this point, both are same. If this is I, 2 amperes, this is 1 ohm, this is 1 ohm, current will be equally distributed. This is 1 ampere, this is also 1 ampere. Now you write that this is 1 ampere and this is 1 ampere. Observe it carefully. Yes or not? From here 1 ampere is coming, from here 1 ampere is coming. Right? Now write the KVL for this outside loop. KVL can be written in any manner. Write the KVL for this loop. Okay, any closed path you can select. So by KVL minus V plus 2 into 0.5 plus 1 into 1. 1 into 1 is equal to 0 because no element here, no element here. You start here, go this way, come this way. That's all. That is only the path. That is only the path, right? Or you can choose another path also, this way, straight, this one and down. That also. You don't go this way. Why? Because we don't know current in that. We don't know current in that. Now from this one, V is equal to what? 2 into 0.5, 1 plus 1 is 2 volts. Answer is absolutely 2 volts. Option is C. Option is C, right? Next question please. Next question please. Yeah. In the circuit, in the current flowing through the voltage source in the circuit shown below is asking about what is this current? What is this current is asking. First of all, this and this both are in parallel. This current is 3 by 4. This current is 3 by 4. 3 by 4 means how much? 0.75. Now this current we don't know. This current we know. This current also we know. Let's take it as I1. Let's take this one as I2. Now according to KCL, from KCL, I is equal to I1 plus I2. So I is equal to I1 is 0.75, I2 is 0.25. So I is simply 1 ampere. Simply 1 ampere. Right? Yes or no? Yes. Let's go to the next question. In the interconnection of ideal voltage sources shown in figure, it is known that 60 volt source is absorbing power. Okay, what about the questions? Or question some statement is missing. Leave this question please. Let's go to the next question. Right? The dual of parallel RC circuit is, yes, the concept of duality. Series RL and parallel RC are duals. Yes. See, dual means KVL equations of one network must be similar to the KCL equations of other network, then those two networks are said to be dual. You write the KVL equation, see, RC network equations you write KVL or KCL. Parallel RL you write, both equations will look similar. See, parallel RC given, parallel RC, then series RL, okay, series RL circuit. Why? Because parallel series are duals. L and C are duals, R and G are duals. So parallel RC, series RL, option is B. Right? Okay, this question we already taken, leave it. Yeah, come to the next question. The total capacitance across points A and B in the given points A and B in the given figure is asking about the capacitance. You see here, very simple thing it is. See, in BEL questions will be of this kind only, no depth questions, but number of questions are more. These two are in parallel, capacitances in parallel will be added. These two are parallel, capacitance in parallel will be added. If that is the case, this capacitance is of how much? 2 microfarad. This capacitance is of 2 microfarad, and this capacitance is also how much? 2 microfarad. And this capacitance, whatever that is left here, this is of 1 microfarad. 1 microfarad. And if you observe carefully, this is A, this is B, and these two are in series. Capacitances in series will be similar to resistances in parallel. Therefore, 2 into 1 by 2 by 3. Yes, this is 2 by 3. So CAB is equal to, this is 2 by 3. 2 into 1 by 2 plus 1, 2 by 3 microfarads. Plus, this is in parallel with this is 2. So CAB is equal to 3 to 6, 6 plus 2, 8 by 3 microfarads. How much it is? 8 by 3 microfarads. So 8 twos are gone. Sorry, 3 twos, 6. 3 twos are 6 gone. 2 is left. 6.66 microfarads. Answer is 2.66 microfarads. Option is B, B for Bombay. Right? Next question. KCL is a consequence of law of conservation of charge. Yes, KCL is derived, yes, from what? Law of conservation of charge. Law of conservation of charge, right? KCL. Sir, KVL is derived from law of conservation of energy. KVL is derived from law of conservation of energy, right? Next, time constant of the network shown in figure is, yes, as I told you previously, the time constant of an RC network is tau of an RC circuit is R equivalent into C equivalent. So tau is equal to, what is the R equivalent? These are in parallel. R in parallel with R into, what is C equivalent? These two are in parallel. C in parallel with C. R in parallel with R is R by 2. C in parallel with C is 2C, because capacitance in parallel will get add. So 2 gone. How much it is? How much it is? R into C seconds. It is what? R into C seconds. Yes, RC only. Option is A. Option is A. Right? Let's go to the next question. In the circuit shown, the switch is closed at t is equal to 0. The voltage across 4 microfarad capacitor in ideal condition is. See, what is the voltage across this combination? This is switch is closed at t is equal to 0. This is plus, this is minus, this is V. Let's take it as V. According to law of conservation of charge, so voltage across these two is same. So can I write Q is a total charge is equal to Q1 plus Q2. What is Q1? Q1 is C1 4 micro. I am not writing micro, but it is micro. I am not writing here. Into V is how much? 24. Sorry, not V is 24. Initially V is 24. After reaching to steady state, the voltage is V plus. What is that? C is 2, V is V only. But what is QT? I am writing QT. QT is equal to Q1. I am taking this one as first capacitor, that one as second capacitor. C is 4 micro. V is V I assumed. V I assumed. Now Q2, yes, C is how much? 2 micro. V is what? V. V is V only. We assume it as V. 2 into V. Now what is QT? QT, total charge, that is there, this one only, that will be distributed. Yes, 24 C into V. V is 24 into C. 24 into 4, how much it is? 96. Now 96 micro is equal to 4 plus 2, 6V. So from this one, V is equal to 96 by 6. Yes, it is 16 volts across both the capacitors in the steady state. How much time? Yes, a question can be given here, that is, yes, for the same circuit, for the same previous circuit. Yes, this is a circuit. Let's take it as C1, let's take it as C2, and this is some V0 initial voltage. This is closed at t is equal to 0. The time taken to reach steady state, by the above network is dash. By the above network is dash seconds. Yes, time taken to reach to steady state is almost, we take it as 5 tau na. Yes, the time for steady state, TSS I will write. TSS is equal to 5 tau, right? What is tau? Tau is equal to R equivalent into C equivalent. What is the R in this one? 0. Therefore, the time taken to reach steady state is equal to 0 seconds. Means within 0 time it will settle. It will settle, right? One more question that is possible on this one is, yes, the current at t is equal to 0 that is flowing in the below circuit, is dash. Option. First of all, let me give you the circuit and options also. So same, it is circuit C1, C2. Let's take this one as V0, and this which is closed at t is equal to 0. The current is I, and I am asking the current flowing at t is equal to 0. I am asking, that is step exponential exponentially decreasing, yes, step exponentially decreasing. Option C is impulse, option D is none. Answer is impulse. Sir, how it is impulse? As the time constant is 0, within 0 time it will settle steady state, it will reach to steady state. Which input will charge a capacitor within 0 time? Impulse input. Which input make current through the inductor sudden change? Is impulse. So as the circuit is reaching steady state, as the circuit is reaching steady state within 0 time, steady state within 0 time, the current flowing in the circuit is impulse. Is what? Impulse. Answer is impulse, right? Let's go to the next question. The transient response to RL circuit can be obtained with. So transient is possible with all these signals, but damn surely you will get a transient response. What is transient? The response offered by a dynamic system which is having energy storage elements for sudden changes. Step signal, yes. What is step signal? Yes, it is a sudden change. Step signal, see, this is a step signal. Till here no input. This is t is equal to 0. Yes, this is t. This is step. Okay. Sinusoidal, yes. Sinusoidal also can give you sudden change. Suppose, but you must switch here. Suppose if you are switching somewhere here, it is a sudden change. But if you close your switch, it is a gradual change. It's not a sudden change. Means if you are closing your switch somewhere, here somewhere, yes, it is a sudden change. Then DC also will give you sudden change. Why? DC is also suddenly changing. But if you are closing a switch at any place, the DC also will behave as a step. But DC means permanently it is there since beginning. Permanently it is there from beginning, right? Any periodic signal also can give you, yes, transient. But among these, which one will give you pakka transient? That is unit step signal. Option is A. Unit step will give you pakka transient. There is no doubt in that. Why? Suppose if you are closing your switch here, no transient. This is since long back it is there. DC means permanently it is there. Already all the elements reach to steady state, so no transient. Here also, this one you are closing your switch at this point. Yes, note, see here any periodic signal also can give you steady state, but it depends. See, this is a periodic signal, this is also a periodic signal. At what point of time you are closing the switch is important. One thing is sure, step signal will give you pakka transient. Remaining may or may not. That there is some condition for that. But step, wherever you close the switch, definitely you will get a transient, right? Let's go to the next question, please. The transient current in an RLC circuit is oscillating. You want the oscillation of the current. If it is series RLC, yes, zeta is equal to 0, yes, zeta is equal to 0, or parallel RLC also, for zeta is equal to 0, the response is purely oscillatory. That implies, what is zeta? Zeta is equal to R by 2 into root of C by L for series RLC. For what? Series RLC. For zeta to be 0, R must be equal to 0. R must be equal to 0. Option is D. Sir, for parallel RLC, what about it is? Sir, for parallel RLC, what about it is? Yes, for parallel RLC, yes, zeta is equal to 1 by 2R into under root of L by C. This should be 0. That implies R must be equal to infinite. R must be equal to what? Infinite. R equal to infinite is not there. He mentioned what? RLC. He did not mention series or parallel. I checked for series, answer is there. For parallel, it is not there, right? Some people will ask, sir, if both are there, what should we do? No, both should not be given, right? If both are given, he must mention series or parallel, right? Next question. The current in the series RL circuit at t is equal to 0 plus E is just now we discussed. Inductor does not allow sudden change in its current. So IL of 0 minus IL of 0, L stands for inductor, is equal to IL of 0 plus. All are zeros, are same as that of previous current. But he said he did not given any previous current. If he did not given any previous current, as the previous current is 0, yes, present current is also, and t is equal to 0 plus also current is 0, but because sudden change of current is not possible. Sudden change of current is not possible, right? Next question, please. A charged capacitor charged at V volts and a resistor R are in series with a switch is closed at t is equal to 0. Which of the following statement is true? He is saying a charged capacitor. Yes, there is a capacitor which is already having some charge. Let's take it as small v naught. Okay, voltage charge is there means obviously voltage is there, right? Q is equal to CV, and it is connected in series with a resistance R, right? And the switch is closed at t is equal to 0. Which of the following statement is true? First of all, this is C. Voltage across capacitor is exponentially decreasing from V naught. Why? Why? There is no source. It is only its charge is only going to give, yes, it is discharging, therefore V naught into e power minus t by RC, right? Current is also exponentially decreasing. So current in the circuit is also, I can write it as V naught by R into e power minus t by RC. If voltage and current are decreasing, power also decreasing. Power also decreasing, in fact, exponentially. Why? Because power is equal to voltage into current, or I square into R, or V square by R, any formula you can apply. The initial charge on C is inversely proportional to the charge stored. Q is equal to CV. Charge is directly proportional to the initial voltage. Voltage is directly proportional to the charge stored. It is not inversely proportional. A is wrong. The current in the resistor varies as 1 by t for t greater than 0. No, current is varying exponentially. That is not correct. The current for t greater than 0 is independent of the value of the C. No, current depends upon the value of the C. Current depends on the value of C, right? This is also not correct. The power dissipated by the resistor decreases as time passes. Yes, power is decreasing. You see, power dissipated by the resistance is decreasing because voltage is decreasing, current is decreasing, right? So yes, let's go to the next question, please. Let's go to the next question. What is this question? What is this question? What is saying? He is saying in the below shown circuit, the independent current source generates 0 current for t less than 0 and a pulse 5t into e power minus t for t greater than 0. Means that current source is I of t is equal to 5 into e power 5t into e power minus 4t, okay, for t greater than 0. At what instant of time will the current attain the maximum value in the circuit? So he is asking when the current flowing through the inductor is going to become maximum, right? Yes or not? If anything is maximum or minimum, yes, its a derivative must be equal to 0. Derivative must be equal to 0, right? That is simple mathematical. 5 we keep outside. T derivative is 1 into e power minus t minus 4 into e power minus 4t plus e power minus 4t into t derivative is 1, that is equal to 0. So yes, yes or not? Yeah, here t will be there, na? Here t will be there. Why 1? Yeah, t derivative is 1. E power minus 4t minus 4 into e power minus 4t plus e power minus 4t into t derivative is why t derivative? This derivative I am finding. Okay, no. Somewhere both derivative I wrote wrong. Yes, I am writing once again. Both I did at the same place. Both I did at the same place. T derivative is 1. This one you write it as it is e power minus 40. Derivative of u into v, na? Derivative of u into v. Derivative of v minus 4 into e power minus 4t into t derivative is 1. That is equal to 0. Right? No. Again, yes. This derivative I did. T derivative I did. That is 1. This is as it is. Then this should be as it is, na? This should be as it is. T derivative I should not write. T already I did. That is the mistake. Number of times I committed. Okay. This 5 will go away. No problem. Right. E power minus 40, e power minus 40 also will cancel as it is common. Now you have 1 minus 4t is equal to 0, that implies t is equal to 1 by 4, that is equal to 0.25 seconds. 0.25 seconds. Yes, 0.25 seconds. Option is A. Option is A. Right? Yes, all of you. See, these are the very good 20 questions for your BEL exam preparation. I covered almost all the topics, okay, all very important topics from the analysis of your BEL examination, right? Yourpedia started its module. You can join a Yourpedia module so that it is going to be really helpful for you, right? All the best and thank you.